but they have momentum. They're pure energy. And at this point, you go, what? Yeah, I know. You can do it in the classical physics or in relativity. You get the same answer. Well, photons have a tiny amount of momentum. So if you have something big enough, low enough mass in the vacuum of space, it gets pushed along. So people have built solar sail missions in the past. The successful one was made by a Japanese aerospace exploration agency, JAXA. And it was about 5 years ago. It went out to Venus and it was going to get an orbit around Venus, but it missed. So now it's an orbit around the sun at about the same distance as Venus. But it was a cool thing. That thing was like 600 kilos, very large. And it got a little bit of push, or measurable amount of push from the sun. The Planetary Society, the Planetary Society, 18 years later, is, what did I say, 18? I think it was 28. Is launching solar sail. So we got an email last night where the launch is slipped to the 20th of May. So for those of you who are planning, you can get down to Cape Canaveral for the launch of our solar sail. So this thing is part of a NASA program called ELENA, Educational Launch of Nanosatellites. So we're going to launch as a secondary payload on an Air Force rocket. For those of you who remember anything about the planetary side, we tried to launch one in 2005 on a Russian Cold War ballistic missile that was repurposed to go into low Earth orbit. But instead of going into low Earth orbit, it's in an exotic area called Barents Sea.
It's really low orbit. God, you wanted low Earth orbit, it got you low Earth.
And there it is, the very compelling Russian inflection. So anyway, this is a real rocket. It's an Atlas V. And the reason I got involved in all this is I had, as I told everybody, I had one course from Carl Sagan. Changed my life. Planetary Society was started in 1980. I got on the mailing list. I joined. I've been a member ever since. And now I'm the CEO. And our beloved Neil deGrasse Tyson is on the board. Scott Hubbard of Mars R is on the board. Jim Bell, the guy who takes all the pictures on Mars. Heidi Hamill, the outer planets astronomer. These are all board members. John Loxton, the world's foremost authority in history of space. And we're going to finally launch this thing. Like it's Carl Sagan's dream almost 30 years later. It's very exciting. It was done by you, by people who just thought it was cool. People who just thought it was a cool thing to invest in because it has the potential to greatly lower the cost of missions to the moon. The mission is aerospace talk for spaceship. Spaceships to the moon, spaceships to the outer planets, well, any planet. And the idea, you guys, when you fire a chemical rocket, a regular rocket, except in outer space, there's no sound system. It burns for a few minutes, and then you're done. Turn it off. But solar sail gets a tiny push all the time, day and night. Except, wait, there's no night. So it's really cool. This thing is very small. It's 10 centimeters by 10 centimeters by 30 centimeters. It's smaller than a shoebox, smaller than a loaf of bread. But the sail deploys bigger than the area of the stage. It's really 32 square meters. And the reason is this stuff is so thin. It's this mylar, super shiny mylar. And this is another thing where you go, no way. And I must say, first of all, way. If it were black, the solar sail were jet black or a black body, you know that expression, theoretically completely absorbed. It would get 1 oomph, one quantum worth of oomph for every photon. But being super crazy shiny, it gets, well, theoretically, it gets exactly twice that because it bounces off. Right? So it's so shiny.
How shiny is it?
It's so shiny that it's quite reasonable that we will be able to see it at sunrise and sunset, even though it's very small, but the orbit is quite low.
Naked eye?
Naked eye, yeah. And it's very reasonable. We'll have an expansion of something called the ISS above, International Space Station. It's a Raspberry Pi computer. You put in your latitude and longitude. You can even put in your altitude. So here in New York, I put it on 70 meters off the street. Charming, hilarious. And it will tell you where the space station is in the sky. So the same guy who's, it's just cool. He's a grandfather who loves computer programming. Liam Kennedy's got another one rigged up for light sail. So you can go to his website, ISS Above, or Light Sail Above, get your little Raspberry Pi, and know where exactly in the sky to look for this thing.
Hey, Bill, you mentioned that the solar sail is as big as the stage. Do you have a feeling for how big a sail has to be for even a small probe?
Well, this is a CubeSat, which is a NASA standard, so you could easily claim this to be a small probe. Right? This is something that you can put a bunch of instruments, and it has cameras. It has heavy cameras, and it has the ability to tack or steer, tack like a sailboat. So it does it with two ways. It has a momentum wheel, which is you and I would call a gyroscope, a spinning thing, and it gets its electricity from solar panels, which are on the outside. And then it has a torque rods. And these are electromagnetic sticks that react against the Earth's magnetic field. It's fine. In low Earth orbit, it works great. It's very well understood. There's no moving parts. The control law is very manageable.
Can I ask you a question about the Mars mission?
Well, I think we just did. Yes, which Mars mission? We love the Mars missions.
Well, Steve told me after, I guess you guys at one point talked last night, Mars one. You gave an opinion about Mars one.
Yeah, well, the thing is, my opinion is correct.